In this video, we're going to talk about the sample standard deviation, more about the concept, like what makes the sample standard deviation so unique. Well, first of all, the letter that we use is going to be the letter S. So keep that in mind. So here it says, if we read over here, it says the standard deviation indicates how much individual values differ from the typical value. So the standard deviation tells us, what is going on from the typical value. The typical value is the mean. What's going on after that, below it and above it. In other words, how much variety of the data is there from the mean. The more variety or more difference there is from the mean, then the standard deviation is going to change, because that's a way to measure the variation from the mean. For example, a dozen eggs, right? Let's say you go to the supermarket and you're buying a dozen eggs, right? And so that's the only thing they sell. So there's always 12 eggs, right, in a carton. In this situation, the standard deviation is 0, because there's no variety of other egg cartons of 6 or 3 or 25 or 18. It's always 12. So if all the values in the data set are identical, there is no variety from the mean, resulting in a standard deviation of 0, which signifies no dispersion of the data. Meaning, again, if you go inside the store and there's always a dozen eggs in a carton, and it's always a dozen, always a dozen, always a dozen, there's no variety. There is no standard deviation. As a matter of fact, this is one of the ways of saying that it's very consistent. You're consistently getting 12 eggs, which in this case is good, because if you go buy a dozen eggs and you get 11, that's not very consistent. But in this case, if you're getting all 12, you're consistent, and it means that there's no variety. There's nothing less or nothing more, but other than 12. In this case, the sample standard deviation is going to be 0. So I think that gives you an idea of the standard deviation. Now, what about oranges, right? So let's say a large standard deviation suggests more variety of the data set, like oranges. You go to the store. Some stores, they have oranges in a pile. Some are large oranges, medium oranges, and small oranges. All these oranges have different sizes, so they weigh differently. Okay? So there's a variety of orange sizes. And so if you have a variety of sizes, in this case sizes or weights, then your standard deviation will be larger compared to if you only have similar size oranges. So in this case, you can see over here with the navel oranges that the distribution goes from 4 to 8. It's 4 ounces. 4 ounces. So you can see that it's a gradual change from the typical value, and then it just goes down. But it's a variety of sizes that gives you the standard deviation to be larger. And here it says the reasons for large standard deviations: a wide range of values. So yes, this weighs a lot more than the smaller one. Diverse values. Again, the values are diverse based on the mean. Okay, so if you have the mean, right, the mean is around here at 6, or the typical value. And if you have a variety of data points, then your standard deviation will be much bigger. It's a measure of disbursement. And then the values are not consistent to the typical value. Now, a smaller standard deviation suggests values are more clustered together. Now, there are these oranges called mandarin oranges. Here in the United States, there's a brand called Cuties. And these mandarin oranges tend to be similar size. Similar size suggests that they might be similar weight. And you can see here the weight goes from 2.7 to 3.3, which is much, much, much smaller in range compared to 4 through 8. Here, there's only like a 0.6 difference in the weight. Here you got 4.0 ounces in difference. So if you were comparing these two types of oranges, you'll say that the mandarin orange have more of a consistent weight because they tend to be more closer to the mean. And the standard deviation on the mandarin oranges will be less. Now, right now, we're not calculating any numbers. The calculations for the numbers are not shown here. But the reasons for small standard deviation, tight ranges of values because it's more closer to the mean, right? These values here are not so spread out and they're much closer to the mean. Consistency with the typical value, meaning if you're consistent with the values, right, close to the typical value, then these particular oranges, the mandarin oranges, are going to be more the same when you choose it. And then the clustering of values is another reason. The standard deviation. So to end this, the standard deviation helps us understand the variation of the data from the mean, offering a glimpse into the data set's consistency and predictability. If the standard deviation, like in this case, if the standard deviation is small, right, or smaller compared to something else, then we know that we can sort of predict the taste and maybe the weight of the fruit. And that's what we want sometimes with our customers. Other times, when the standard deviation is larger, then we're expecting different sizes in this case, the oranges. Oranges that are small tend to be sweeter than larger oranges because there's more water in the larger oranges. And of course, if you sell these oranges, maybe you don't want small ones or large ones. Maybe you want medium-sized ones because that's what your customers want. And again, if the standard deviation is 0, it means that all the values are the same. There's no variety. It doesn't vary at all. It's just consistently the same. And we can really predict. The prediction is it's going to be 12. It's going to be 12. And sure enough, it's consistently enough, and it is 12. Of course, once in a while, there's always one that's cracked. But either way, I think you'll be surprised that the standard deviation just adds to your tool belt as a data detective. All right, I'll see you very soon. I hope you have a great day, and bye-bye.